So, who makes software? Where did the mind-boggling array of roles that we've got right now come from? We're going to track the evolution of these roles over history, and we're going to see a pattern emerge that we can use to understand any technical role, and predict how technical roles will emerge in future. Our timeline is going to start around the 1970s, with the breakthrough of the commercial computer. These computers are huge and they're expensive, and they only exist in big organizations like the stock exchange or the aviation index, anyone that can afford them. These organizations are building big digital versions of their current systems, so it's really the first kind of digital transformation. This digital transformation requires three roles. There are application programmers who actually build the systems, and they're responsible for writing the code, translating the pen and paper booking systems into ones that run on computers. There are system programmers. These people make sure that the computers and networks which run the stock exchanges are all working. And there are security engineers who keep all these systems safe from being abused. Almost all software is custom built, and in general, software will only run on computers built for that software, also known as mainframes. And as a side note, early programmers, application and system programmers, invented technologies to make their jobs easier. So, from the 70s, we start to see things like C, SQL, and Unix emerge, and all of these are still very popular today. We're going to see that this spirit of invention enables further technological progress, and it starts to define technical roles. Let's fast forward to the late 70s, early 80s. At this point, we've got a pretty major breakthrough with the microcomputer, and easier-to-use technologies that I mentioned, C, SQL, and Unix, are starting to become mainstream. Many more people can become programmers than before. Up to this point, computers were huge, and really they were only used for huge government projects, like the Apollo mission or in academia, or by huge organizations that I just mentioned. But from the mid-70s, microcomputers mean companies can sell thousands of copies of programs without making the computers too. For the first time, it's possible for companies to buy and build software products. Word processing is the big opportunity here, so companies like Microsoft, Micropro, and Lotus are leading the way. Roles-wise, while system programming has continued to be very important in big institutions, application programmers are where the real growth is happening, and cybersecurity continues to grow in the 80s with the advent of the personal computer. Okay, let's fast forward a little bit and head into the 90s. So again, there's been another technological breakthrough, and that's the World Wide Web. Companies are taking advantage of the new opportunities. Companies like Netscape, Apple, and Microsoft are starting to get big. Application programmers are coming under stress to program complex things like illustrations, maps, images, and animations, all in a brand new environment and using the brand new HTML language. There aren't really technologies at this point to make this stuff very easy, although they are being invented, and so there's lots to keep on top of as your average application programmer. So we start to see the application programmer role split into front-end and back-end. Front-end engineers focus on making sure that the illustrations and maps and images and animations and so forth all work, that they're delivered really quickly across the old dial-up connections, whereas back-end engineers are focusing more on building the systems behind the scenes to support this content delivery. As a note at this point, the full-stack engineer is someone who can work across both the web front-end and the web back-end. Of course, all of this code still needs somewhere to run, and it was common to have a physical computer sat in your office, perhaps in a special server room, where it would serve your website's content to customers over the web. Systems programmers, which are splitting into system administrators, or sysadmins, and system engineers, are making sure that servers do their job effectively. And what about cybersecurity? Cybersecurity is growing too, in response to threats. You see, the growth of the web in the early 90s led to a spring of viruses, and an explosion in antivirus software. As a result, we see cybersecurity specialisms start to develop. There are security administrators who work to keep server rooms safe. There are security engineers who work to build safe programs, including antivirus software. Let's take a little break to notice a couple of patterns. Firstly, what's driving these role specialisms? What's driving the explosion in titles? The answer here is increased technical complexity and stress. Secondly, can we see a pattern across these role titles? One pattern to notice here is that the engineers are building things. They write code files, and administrators manage that code once it's running on a server. These two patterns are going to stay consistent throughout. And we'll see in a few minutes that cloud administrators and DevOps administrators fit here too. Remember the spirit of invention that we talked about earlier that leads to new technologies. In 1995, there's a huge explosion of web technologies, and this enables faster, better coordinated front-end and back-end development. So we have Java, PHP, JavaScript, and Ruby, and they all emerge around the same time in 1995. And this really sets the stage for what happens next. So let's look at the late 90s. So far we've had websites, but the big technological breakthrough in the late 90s is web apps. And this is enabled by the web technologies that we just mentioned, and growing adoption of the web in general. It becomes possible to write huge systems. Companies like eBay and Amazon, founded during this dot-com boom, take advantage of this opportunity, and they basically invent e-commerce. It becomes possible to run systems in huge data centers at this time, and so products like search from Yahoo and Google also become viable as a result of this data center growth. Big systems cause new kinds of problems, and around this time we get two sorts of big scaling problems that happen. The first one is that applications are getting very big. There's a lot of lines of code. There are lots of moving parts. Some applications are handling payments and validations and logins and logging out and buying tickets in multiple countries around the world, and all of this has to happen very quickly and very consistently from anywhere in the world, regardless of where your data center is. The second big problem is that we're seeing big teams. We're getting thousands of developers working on a single unit of code, and so working practices have to adapt. The problem where applications are getting too big gives rise to a new set of roles in the system tradition, which are Site Reliability Engineers or SREs. This is a specialist discipline of systems engineering, and it's pioneered at Google in the early 2000s. SREs make sure that the big applications stay online at all times, and they're measured in uptime. The second problem, that teams are getting too big, really gives birth to Agile. Agile has been around since the 70s, but it becomes much more popular in the 90s. Agile is about coordinating the work of these large numbers of developers to ensure they're building the same big application without breaking it, in a way that embraces the rapid change of pace we've seen so far. It doesn't get called Agile officially until 2001. So, we've still got front-end, back-end, and full-stack engineers, but now they're often working in agile ways. SREs join sysadmins and system engineers. And what about cybersecurity? Security continues to grow because the web apps are handling more complex payments, logins, and details. One last thing about this era. Remember that I mentioned the growth of search as a product within Yahoo and Google. Search works by managing, organizing, and querying large amounts of data. For example, web pages and the content of web pages. This gives birth to data scientists and data engineers as a whole new discipline, and they work together to turn huge volumes of poorly structured, chaotic data into searchable formats. At this point, let's take a little break to notice another pattern. And this pattern is really well known by technical people. It's going to help us to predict how roles developed from the 2000s to the present day and then into the future. This pattern pretty much always starts with a tech breakthrough. Where do these technical breakthroughs come from? Well, usually they come from technical workers or researchers. They build tools maybe to make their current jobs easier, or for research, or to make their company more competitive, or just for fun. And in doing so, they invent a whole new way to make, run, and distribute software products. Maybe it's the microcomputer, the web, or a new programming language. In response to this tech breakthrough, new products come to market at companies that are able to take advantage of certain opportunities from this breakthrough. And in response to that, the existing tech workers who were there begin to split out into increasing levels of specialization. Now, this specialization happens because the post-breakthrough world is more complex than the pre-breakthrough world. The systems are getting bigger and they serve more people. So, for example, we might see the humble application programmer develop a specialism as a front-end engineer or maybe as a back-end engineer. Let's return to the timeline. So in the 2000s, the big breakthrough is cloud computing. Up until this point, you either have to run a server in-house and employ system engineers and systems administrators to keep it running, or you could rent a whole computer in a data center somewhere and pay for its upkeep. In 2006, Amazon launches AWS, Amazon Web Services. Now companies don't have to rent a computer at all. They can just rent the parts of one that they need, and they can do this in a flexible way. They can double or triple the scale of their system in minutes, not in days or hours. So suddenly, it becomes much easier to deploy and develop an application. Big social networks like Facebook can easily scale on the back of this. The entire software as a service industry suddenly comes into being, and computer-intensive streaming services like YouTube and Netflix suddenly become viable companies. The complication of cloud is that getting a system to run on a server is much harder. On the cloud, engineers have to work out how to run and manage systems in flexible ways on many different parts of servers without slowing down application development or making the systems more likely to crash. These challenges get a particular name, and that's deployment. The main area of deployment is in the systems engineering tradition. And so, within this area, we start to see infrastructure engineers, or infra for short, and they specialize in managing all these virtual cloud servers. We have platform engineers who develop ways for application engineers to deploy product features easily. In 2009, this group gets a singular name, Devops. This name is meant to convey that they work both as developers writing code, but also as operations specialists organizing and managing systems. They're both managing the products that the company makes through deployment, but they're also managing the systems of developers who write those products. They may not be line managers, but they may be writing tools which help to manage and coordinate application development work. Meanwhile, cybersecurity continues to grow. From 2007, we have the mobile internet, the Internet of Things, there's even software-enabled automobiles. And this increased prevalence of software makes it ever more important to keep secure. Cloud also enables one other big change. Remember that Yahoo and Google were working on search by organizing data? Well, before 2006, you had to buy and rent giant server farms to do that sort of work. And that was out of reach for most companies. After 2006, the introduction of AWS and Hadoop puts this power in the range of non-tech giants. And so we start to see analytics and recommendation companies emerge as we head into the 2010s. With them come data engineers and data scientists who comb the data and build the engines that power these products. So where are we now? What are the technological breakthroughs of the current day? There are many. New interfaces like Amazon Alexa's voice user interface or Oculus's virtual reality are driving growth and specialization in application engineering. Artificial intelligence and machine learning is driving specialism in data. There are distributed systems which are driving growth and specialization in DevOps. And the fractious geopolitical landscape of the modern day is driving growth in cybersecurity.